Alright, now let me elaborate circuit switching a little bit more. This is the familiar network. But this time we see on the network there are two circuits. The red circuit connects this end to this other end. Similarly for the blue end. And to establish such a red circuit, which is also called a call sometimes, and the time it takes to set up such a call or such a circuit is also called the call setup time. Okay. And the reason that I need to mention that term is because that takes time, because resource reservation is required going from one end to another, which means this is the first link on the circuit. We need to reserve a certain amount of bandwidth to guarantee that data gets transmitted without any loss or delay. So you reserve link bandwidth for the call. Data is going to go through a switch. This is the first switch. On the switch, memory, CPU, buffer space will also need to be allocated and reserved. So that is what I meant by switch capacity here, to guarantee that the packet will not experience delay and not experiencing any loss. Similarly for the second hop, for the third hop, fourth hop, fifth, sixth, seventh, and eighth. When all 8 hop link bandwidth switch capacity reservations are done, then you build a circuit. But then you see, as Polly was describing, this circuit here, resources are all dedicated. When data are being passed to, no delay, no loss. Really nice. And we call that circuit-like performance. That implies delay and no loss are guaranteed. Low delay, no loss, guaranteed. Similarly, for the blue circuit. And this is really nice because zoom into this segment. This segment here shared by the blue circuit and the red circuit. The two of them, although packet or data will be going through, but these data will not interfere with each other, not incurring delays to each other, and not collide to each other. No packet drops. These days, where we do online meetings a lot, having live YouTube channels a lot, we'd really like to have this circuit-like performance. This way, we don't have to worry that the internet is going to go bad and the live stream is going to break at some point. Nice. Because for certain applications, we do need this type of quality of service. But, you see, establishing the red circuit, we need 8 hops, and each hop takes some time to reserve resource. So there's quite a bit of call setup time involved. This is the downside of circuit switching. Another downside is this. The way we are allocating or reserving resources over the entire path from the two ends of data communication is more. We divide the link bandwidth into smaller pieces. We divide the switch capacity also into smaller pieces. And once we do that, we allocate individual pieces or combinations of pieces to an individual circuit or individual call. But once you do that, if there are no data being sent between the two ends, that piece of resource will then be idle. If you think about it, in a way, it's a waste of resource. If the two of them ask for resource and a call established, but they're sitting doing nothing. So not very good utilization of resource. So this is the second disadvantage of doing circuit switching. Now, speaking on dividing link capacity into pieces, there are multiple ways of doing that. First one is called frequency division, the other time division. This is the second time we see the term TDM. Where did we see this? Yeah, cable modem. We divide cable modem capacity. We divide the cable network link capacity into what? Pieces by the frequency band. This is a very different flavor. Okay, it's dividing the link by the time. Let me illustrate. The example on the top is doing FDM, where we divide the entire frequency band there to 4 users in equal division. So, full frequency band, 1/4 to the blue user, 1/4 to the green user, to the yellow user, and the pink user. TDM works this way. Instead of dividing the frequency dimension, that's divide, okay, in the time dimension. So with these time slots, we allocate the time slots in a rotating fashion to the 4 users like this. Blue, green, yellow, pink, blue, green, yellow, pink. Yeah, it's rhythmic. That is exactly how TDM works. With a good rhythm, with well-synchronized time, the 4 users can send data one after another. Very orderly. If we have more than 4 users, how do we do that? You see, we could further refine the division into, for example, A parts. That way we can accommodate how many users? A users. Similarly for TDM.